Hello students. In the previous class we have seen about the advanced functions and we have seen particularly about three different functions, that is inline, friend and virtual function. Okay. In today's class we are going to see about the last two functions, overriding and the pure virtual functions, and we are also going to see example programs for both overriding and pure virtual function. So overriding functions. And the function of the overriding is actually it's redefining a base class function in the derived class. Okay, they must have a same signature and it achieves polymorphic behavior. Let's see how it's being done with a code here. Let's just see a small code snippet here. You can see class derived public base and void display override. Actually, here I'm defining a class named derived, which is publicly inherited from the base class, right? That's what the meaning for this. So inside this class, I declare a member function, okay, that is display, that is overriding the virtual function from the base class. Okay, so the keyword override here explicitly indicates that this function is meant to override a virtual function in the base class. This helps the compiler to catch mistakes if the base function signature changes. So that's what I wrote here. The override tells the compiler this function is supposed to replace a virtual function from the base class, and the compiler will result in error if the signature differs. Okay, so note that this function is only declared here and its definition will be provided outside the class. It's a key point to remember, students. Again, I repeat, note that the function is only declared here and its definition will be provided outside the class. Okay, so finally, this actual dispatch to the derived implementation at the runtime, it's done by vtable, that is virtual table, on vpointer, it's virtual pointer mechanism, so resulting in a dynamic dispatch. Let's take a detailed code to explain that. And as usual, let me begin by including the IO stream header for input-output operations. So next, I'm defining a structure here named base. Inside the base, I declare a virtual function display. I also declared a virtual destructor using virtual tilt base is equal to default. Actually, this is a very good practice because it ensures that when a derived object is deleted through a base pointer, the derived destructor is correctly being called. So next I define a struct named derived, which inherits publicly from the base. So in the derived, I override the display function to print derived display. Okay. Inside the main function, I create a pointer of type base and point it to a new derived object. So this sets up a scenario for dynamic dispatch, the key aspect of your function overloading. So when I call bDisplay, the virtual function mechanism ensures that the derived version is executed at the runtime and not the base version. So finally, after doing this, I delete the pointer b because of the virtual destructor which we have used, the derived object is safely destroyed here. That's how it's preventing the resource leaks. So finally, I can tell that this code, it demonstrates runtime polymorphism, dynamic dispatch, and also proper cleanup here. Hope this is program is clear. Anyhow, for you to understand, I made no step-by-step execution here for the same coding which I have explained you now. So the step one tells the class definitions. So base has two functions, virtual function and a virtual destructor, as I told you. So virtual function for display and virtual destructor using the tilt base. Now derived overrides a display with override keyword. The compiler checks the signature is right or wrong. So this is coming for, let's take a step one, which defines the class. Step two, let's delete for memory and object creation. So new derived, it allocates the memory for a derived object. Inside the object, the compiler places a hidden virtual pointer. Since the object is derived here, its virtual pointer points to the virtual table for the derived. So the vtable entry for the display points to the derived display, here. Coming to the step 3, let's talk about the virtual function call. Because display is virtual, the compiler generates the code to look up the virtual pointer inside the object. It jumps to the function pointer in the virtual table at the slot for display. Since B actually points to a derived object, the vtable points to the derived display. Hope this is clear, right? So hence derived display runs printing. Okay. So coming to the object deletion, B is a, we have given here, right? So base, this is a base thing, but the object is actually derived. Because the destructor is virtual, the compiler looks up for the destructor via the virtual table. So this ensures derived. So therefore derived runs first if defined, followed by the base. This is how it's preventing the memory leaks and undefined behavior. If you want, I will repeat. Because of this virtual destructor, the derived object is safely destroyed. So it prevents the resource leaks. Okay. So coming to the summary of the virtual function, which you have seen with an example here, virtual function and the things we have seen here, and it enables the runtime polymorphism, and the override, it ensures the function matches a base virtual function, and dynamic dispatch, it correct function is to chosen at the right time and not at the compile time, is running at the runtime. A virtual destructor, it ensures proper cleanup when deleting the derived objects via a base pointers. See, I have concluded just in three lines, just a single sentence. Mark the function virtual in the base. Okay. Implement it in the derived with the same signature. That's using override. And at the runtime, calls calls to the base pointers or references or dispatch to the derived code via the virtual pointer or the virtual table, the function pointer lookup. Okay, so this is how the virtual functions being used, virtual functions and override functions being addressed in this code. Let's come to the last part of the advanced function, that is the pure virtual function. So pure virtual function, actually it's declared as is equal to 0 in the base class, and it's no implementation in the base class itself, and it also makes the class abstract. Very keywords to understand. We will see how it's in the program when we talk about it, and derived class must implement it. Okay, let's take a code snippet here. Class shape, and we have given a virtual void draw, and let's make it as a pure virtual function. A pure virtual function is a function in a base class that has no implementation and it's meant to be overridden by the derived class. Okay, see, it's, as I told you, it's declared by assigning equal to 0 in the base class. Okay, so virtual void draw is equal to 0. The shape here is now an abstract class because it has a pure virtual function. And any class that derives from the shape must implement the draw. Okay, I have written a code here for this. Let us take the same example for the class shape, and let's see how it's being done using the pure virtual functions. So I start by including the IO stream header and using the standard namespace for input and output as usual. Next, I define an abstract class named shape. Okay, here, as I said here, it has a pure virtual function draw, which is declared as virtual void draw is equal to 0. So this is a pure virtual function and this is an abstract class. Being the pure virtual makes the shape an abstract class. So we cannot create any objects of this class directly. Hope this point is very clear. Now I define a class circle that publicly inherits from the shape. In this class, I override the draw function to print drawing circle. Similarly, I define a class square that also inherits from the shape, overriding the draw function to print drawing square. Okay, now let's come into the main function. I create two pointers of the type shape. S1 pointing to a new circle object and S2 pointing to a new square object. This shows polymorphism using the base class pointers. Please note that this shows the polymorphism using the base class pointers. So when I call S1 draw function draw, the circle draw function is executed, printing drawing circle. Similarly, when I call S2 draw, it calls the square function and helps in printing drawing square. Okay, so finally I delete both the objects using delete S1 and S2. Why do you need to do it? To release the allocated memory. So thereby what do you achieve? Avoid memory overleaks. Okay, so this program demonstrates, I can tell you, it demonstrates abstract class here, pure virtual function. It also helps in runtime polymorphism. So coming to the just points to remember for this, this two which we have seen already now, maybe if you're just a point to refer for you, shape here, a new circle creates a circle object but stores it in the shape. Since the shape has a pure virtual function, the virtual table ensures circle draw is being called. Similarly, S1 draw. It helps in runtime polymorphism. It looks at the virtual table of the circle and it calls the overridden function circle draw. So I can conclude that a class with at least one pure virtual function, it becomes an abstract. And you cannot instantiate an abstract class. Derived class must override the pure virtual functions, otherwise they also remain abstract. The pure virtual functions are the foundation for achieving the runtime polymorphism in C++. So coming to the summary of all the five advanced function, just in a keyword like a phrase, I can tell that inline function, it helps in optimizing for the small functions. Friend function, It is used for external access to your private members. Virtual function, it enables runtime polymorphism. Overriding, derived class redefines the base behavior. And pure virtual, it forces the derived classes to implement. Okay. So with this, we end up the advanced functions. Thank you.